All right, you guys, this is our second example of a titration problem. So you're going to see how this one is a little bit different than the one we did the other day. And I'll talk you through that so that you'll be able to do the rest of the worksheet. So let's start. We've got our problem here. And again, our first job every time we do a titration problem is to write the reaction, right? It does need to be balanced. So I'm going to pay attention to the chemicals they give me. They give me sodium carbonate reacted with, and then I'm having to look through it, hydroiodic acid. So it's probably going to be the hardest part for a lot of you is just writing the reaction. So sodium carbonate, we check our charges. So again, there's a link to the ion sheet for you. Sodium is +1, carbonate is -2, so it's Na2CO3 added to hydroiodic acid. It's kind of strange. This means that our ion ends in "ide," so I'm looking for iodide, which is I, -1, with the H, which is +1, so it's going to be HI. So again, this is a double replacement reaction. This one's different because it does not form water. It forms H with CO3. I check my charges, +1, -2. It's H2CO3, plus my sodium and my iodide, +1, -1. Be careful, this 2 came from the carbonate. Sodium's just +1, so it's NaI. Now, unlike our last example, this one does need to be balanced. It's not balanced right now. I'm going to put a 2 here in front of my NaI, and then I need a 2 here in front of my HI to balance this reaction. So that's my first job. And again, take your time with that. Do a really nice job of balancing that reaction so that you have the right mole ratios. Remember, the whole point of writing the reaction is so you have the mole ratios for that step. So the mole ratios, again, are the numbers out front when you balance. Okay, so step 2, I'm going to write down the information they give me. And this is different because there's only 2 bits of information. I've got the 0.151 grams of sodium carbonate, so I'm going to write 0.151 grams here. And they also give me the 13.3 milliliters of hydroiodic acid. It's asking me to calculate the molarity of the hydroiodic acid solution. So this is what we're trying to find the molarity of. Step 3, find the moles of our known. So our known here is, remember, whatever we're not trying to find, it's my sodium carbonate. Now in the last sample problem, we used this formula to find moles, right? We use molarity over 1 equals moles over liter to find moles. We're not going to use that here. We're going to use a different way of finding moles, and it's one we've been using since last semester. If I have 0.151 grams of sodium carbonate, I can find moles by doing a 1 bracket formula mass problem. So I'm going to put grams on the bottom, Na2CO3, and 1 mole on top. It is not a long stoichiometry problem, it's a 1 step, and we're going to find formula mass. We have 2 NAs, 1 carbon, and 3 oxygens, 22.99, 12, and then 16. And we're going to add that all together. So I'm going to go ahead and take out my calculator and get that calculated right now. So I'm actually doing that at the same time you probably are. 22.99 times 2. I wish some of our fast calculator people were here to help me out. Plus that, I get 105.98. So I'm going to put that right here. And that cancels out. So I'm going to go ahead and take my 0.151 divided by that number. 105.98. 151 divided by 105.98. And I get, for an answer, 0.00142 moles of sodium carbonate. All right, I know who's going to be concerned about that, how many sig figs and that sort of thing. It's actually quite a few more digits that I'm keeping in my calculator because I don't have the answer to the question yet, but I'm just being lazy about writing them down. So again, I'm not clearing my calculator. I'm leaving that number there. Okay, so step 1 was reaction. Step 2 is to write down information. Step 3 is to find my moles of known. I just did that differently this problem because I was given grams. Step 4, if you look back at your notes from yesterday, is to use the mole ratio. So now I'm going to go ahead and just set up another bracket. And by using the mole ratio, what I mean is we look up at the balanced reaction and we look at these numbers out front. Okay, that's what the mole ratio is. For every 2 moles of HI, I have 1 mole of sodium carbonate. So sodium carbonate needs to go on the bottom. 1 mole of sodium carbonate per 2 moles of HI. So again, I haven't cleared my calculator. I'm just taking the number that's on my calculator right now, times 2 divided by 1, and I get for an answer over here 0.00285 moles of HI. And moles of sodium carbonate cancel. All right, final step, step 5. Find our concentration of our UNC, which is our unknown. Our unknown in this case is HI. So just a reminder, concentration is molarity. This is the formula. M over 1 equals moles over liters. Here's our moles, and we're going to get our liters from over here. That value is going to go at the bottom. So I'm going to go ahead and write this out. M over 1 equals moles, 0.00285. And again, I'm leaving that number in my calculator, divided by my liters, which is, if I move that decimal 3 to the left, 0.0133 liters. And I'm going to get my answer. So let's go ahead and plug that in. Again, I haven't cleared my calculator. And I get for an answer, rounding to 3 sig figs. Again, to figure out sig figs, I look at the very start of the problem. 3 sig figs and 3 sig figs. I'm going to round to 3. 0.214 M is my answer. All right, so now you have enough information to do the rest of the problems in the titration part of this packet. And again, the hardest part is probably going to be writing the reaction and getting that balanced correctly to begin with. But then just follow these steps, step by step, to find that molarity each time. Good luck.